Today we are solving diameter of binary tree, LeetCode 543. The diameter is the number of edges on the longest path between any two nodes. Here is a quick example. The root is 1, with children 2 and 3, and node 2 has children 4 and 5. In this tree, the longest path is 4 to 2 to 1 to 3, which has 3 edges, so the diameter is 3. Now here is the trap. Many people only check the root, using left height plus right height. That works sometimes, but not always. The real diameter does not have to pass through the root. In another tree, the longest path from the root side might look like 1 to 2 to 3 to 5, which is length 3. But the true longest path can be 5 to 3 to 2 to 4 to 6, which is length 4. That path stays inside a subtree and never goes through the root. So if we only check the root, we can miss the correct answer. So what is the reliable approach? We visit every node. At each node, we compute a candidate diameter, left depth plus right depth. Then we keep a global maximum across all nodes. The largest candidate we ever see is the final diameter. We do this with post-order traversal. Define a helper function called depth. If the node is null, return 0. Recursively get the left depth and right depth first. Then left plus right is the candidate diameter through this node, so use it to update the global max. Finally, return this node's depth to its parent, which is max of left and right plus 1. In Python, one common trick is to store the answer in a one-element list, so the inner depth function can update it. The complexity is efficient. Time complexity is O of n, because every node is visited once. Space complexity is O of h, where h is the tree height, from the recursion stack. Let us run the first example quickly with post order. We visit node 4 first. Both child depths are 0, so candidate is 0, and node 4 returns depth 1. Node 5 is the same and also returns 1. Back at node 2, left depth is 1 and right depth is 1, so candidate is 2. Update global max to 2. Node 2 returns depth 2. Node 3 has no children, so it returns depth 1. Back at root 1, left depth is 2 and right depth is 1, so candidate is 3. Update global max to 3. Traversal ends, and the final answer is 3. That is the whole method. Post-order traversal. Compute left depth plus right depth at every node, and track the largest value globally.